Today we're going to show you how to use 35.5 grams of SiO2 and 66.5 grams of HF react to a yield of 45.8 grams of H2SiF in the following equation and work with a set of following questions. Our first question is how much of the excess reactant remains after the reaction ceases. So we have to find the limiting reactant. So our first equation is 35.5 grams of SiO2 times 1 over 60.11 times 1 over 1, which would be the ratio, and as a product we would get 0.5908. Then we have to do the other reactant, which would be 66.5 grams of HF times 1 over 19.91 times 1 over 6, which would be the mole ratio. And as an answer, we would get 0.5567. So we later find out that the limiting reactant, which would be 0.5567, which is HF. Next, we subtract those two numbers to find the excess of the moles, which would be 0.0341. Then we have to convert it back to moles, so we go 0.0341 moles times 60.0855 over 1. And as a product we get 2.049 grams of SiO2. Our second question, what is the theoretical yield of H2SiF6 in grams? And those top two equations shows how we found our limiting reagent, and we found that our limiting reagent was 0.5567. So we multiply 0.5567 moles of HF times 144.1055 over 1 mole, and we get 80.22 grams of H2SiF6, which would be our theoretical yield. Our next question was, what is the percent yield? And the percent yield is the experimental yield over the theoretical yield, and the experimental yield was 45.8 and the theoretical yield was 80.22 times 100, and that would get us 57%. Our fourth and final question was, what kind of reaction is this? So there's the balanced equation, and we found that it was a replacement problem. Thank you for watching.